Right, hi guys. Previously we talked about lag time, slack time, and different type of relationship between job activity, and then we also talked about the milestone that we set for in the project based on the completion of certain group of activities. So what we want to talk about here is more on tracking of the project. So we have finished doing the program of the project, so we want to track whether your project is ahead of schedule or behind schedule, so you need to expedite the work. So this is the tools. This is the tools for you to track your project. It is called project curve. Project curve, you might call it S curve because it looks sort of like an alphabet letter of S. So project curve. Project curve is a plan progress curve. A plan progress curve is obtained by calculating the cumulative cumulative. This is the word cumulative tools. So the is the cumulative. It's mean compounded, adding up cumulatively. Cumulative tools to of the chosen progress measure. Why chosen? Because you can have progress. You can have financial project curve, or you can also have the physical project curve. So basically, financial is based on your costing. That's what we've done in the lab session. So we developed the S curve or project curve based on the costing for each task. And also we can have that physical curve. Physical curve is based on the percentage of the work, how much days are being allocated for each task. Basically, how the duration of each task. So basically, what physical curve view with that. Uh, the idea is that if that task having bigger duration means that that task is very critical to the project, contribute large percentage of completion to the project. So physical curve is another thing, financial curve is on another aspect. But people are more project team are more inclined towards the financial curve because it's about money and cents, how much you pay, how much you are getting paid, and how much you are spending your money, you are investing your money towards a project. So it's about money and cents. It's more tangible compared to physical, where physical is based on how many days you allocated, you slotted, you have put on that work, on that activity. So you can have longer activity, but it doesn't really represent the work because it can be changed. But money and cents you cannot change because uh, it it is very tangible, and it is your money to be spent. You have spent, to be spent, or you have spent. So but days, weeks, or months can be used in the preparation of progress curves, depending on nature of extent of work. So if it is a long project, it's a 5-year project, so it'll be months. But if it is a short project, some of the project not that long, like taking like 6 months, very short duration project. So it will be in days or weeks. If the progress values are plotted at short time intervals, the resulting curves are apt to be irregular and jerky in appearance. So if it is too short, so your S curve will be like a very let's say you have two curve here but with two different in time intervals. Let's say if you plot in days, it'll be like very short here. It will if not in weeks, it will be much more gradual, um, gradual curve. So you should find it which one that is more appropriate. Depends on your total duration of the project. So plotting values as of the end of each month normally results in reasonably smooth curves. So the book the books is suggesting to use months. and but we cannot, you know, disregard the fact that some of the projects are only being handled like in a few months, so plotting would be in a few weeks or days. A common and very effective procedure in plotting of planned progress curve is to produce two such curve. One is determined on the basis of all project activities starting as early as possible, and the other is based on project activities starting on the late start dates. This is the plotting on the physical curve. So you can plot it on early start. One is early start, as you can see here. Uh, uh, One is based on the early start, and another one is based on the late start. So when these two curves are plotted, they form a closed envelope. So they form an envelope here. So they meet at this point, starting on this point. So they are enveloping a certain area here, specific area here. So these curves are commonly referred to as curve, as I said before, because of their typical appearance. After two extreme condition curves are drawn, an average curve between them is sketched in. So based on the duration, based on the early start and late start, so you can have the uh, average curve here. So you can based on the figure. So these are the figure two. So you like take a middle portion of it. So this is your uh, average start date. Average start date lah. This one, this dotted line is your average start date. So the average curve is shown in dash line and is used for purpose of general progress monitoring. So this is your general progress monitoring. So let's take a look at this graph. So you can see here, this is your early start. Top one is your early start, and the bottom one is your late start. So you can start earliest you can start is this curve, and then the latest you should start is this curve. So you cannot exceed this curve. Uh, as shown in here, this your actual progress. So you can you can go further more than this planned late start progress. If you do that, so your project will be delayed, because delay, or you need to expedite uh, the next activity. So you need to shorten the activity of the next task. So this basically is a tool. So if you plot, each time you plot, so you'll be presenting this, and to provide justification that your project is still within the schedule, is still on schedule, and there's nothing to worry about. Same for this one. So the progress has been expedited. So you can see here it's closing into the early start of the project. So that is project curve, based on early start and late start. So during the construction period, actual progress is plotted, as you see earlier, periodically. So with these points forming the actual progress line. So these are your actual progress line. So the relative position of this line to the planned average progress curve is used to evaluate the time status of the project as a whole. So as a whole, you can evaluate the status of the project. The time status, is it delayed, or is it ahead? So where actual progress plots above the average progress line, the time status of job is considered to be satisfactory. So if the actual progress plots above the average progress line, it is satisfactory. When it lies below the average progress line, for example in here, so this is unsatisfactory. You need to expedite. It won't affect your finish time, but you need to expedite, because if it keeps on the late start, some of the activity might cause delay to your project. So basically it's a tool, very fine tool to monitor your project. So rule of thumb often used is that 50% 50% of the job is accomplished during the middle one-third of the construction period. So one-third, 50%. So let's say divide into 3. So one-third is 50%, and the other 50% is be divided into, one-third, 50% is here lah, in the middle of two-third. So 50% of the project need to be completed here. So another 25 here on the final thirds, and then another 25% here for the project. So that's how you get the more gradual S curve. So this is basically on the duration. So this curve is basically on duration. What we've done before is on costing. But we didn't change the cost. We just changed the duration. It also affect the cost. So the location and ES and early start, earliest finish curve with respect to one another depends on the relative amounts of activity load present. So your EF and ES curve depends on your float. If there's more float, if the float tends to be small, if there is many small slack time, so the two curves will be close together. And the shape of envelope will be long and thin. If a relatively large amount of float are present, the two curves will become more widely separated. So it depends on your activity flow. Consequently, the shape of the envelope gives a quick visual indication of the degree of time control required to keep the project on schedule. So it gives you some sort of gauge. So you have a sense of time control. So if narrow envelope, you can see here, if narrow envelope require more rigorous time control program. So you really need to control your task. You don't have any large amount of slack, large amount of float. So everything need to be on schedule. You need to control if it is delayed, if it is being delayed. So, but you have very small opening, very little days of delay that is acceptable for you to maintain the finish date of the project. So a narrow envelope will require considerably more rigorous time control program than will a project where the envelope indicates the presence of substantial fluid. So if you have a wider envelope, so means you have larger fluid on certain tasks, larger percentage of fluid, so you have a larger degree of time control, so you can delay a bit more. The project won't be too hard now because you have a lot of time to adjust your task. Let's say should there be any problem on the project. And also another one, narrow envelope also present more difficulties in resource allocation because of limited fluid. As you can see, if it has limited fluid, so a lot of resources need to be focusing on the task. So you need so basically it means that you need to spend more money. You need to have more workers to finish more job on a short period of time. So it be like large concentrated of resources. Let's see here. So it helps you either you in the client side or in the contractor side. It helps you evaluate the project, whether it is viable, is achievable to be completed or not, based on the time duration. So this is example of S-curve physical S-curve. Based on the duration, physical, like before. So based on this, just want to show you. This is actually your master plan on the start of the project. So this is the curve. So the first curve here to be completed like August, in August. But then You have EOT1, extension of time 1, extension of time 2, 3, 4, 5, 6. So based on the extension, so you're projecting your new curve, physical curve based on the adjusted duration. So basically after EOT, you can adjust your duration for each task. What is completed, so it's completed. For example, in this example here, so task has been completed up to here. So beyond this, the duration, the start date, early start, the start date can be adjusted to suit your new granted EOT. So in EOT1, in OT, client will provide you more days to complete. So based on that days given, you can adjust your duration. But bear in mind, the duration given to you is not like granted, like rightfully granted to you. But it is it needs to be justified. It need to be, the wrong is the mistakes on the project is the delay is not caused by the contractors, it's caused by client. So if you're on the client, the contractor side, you need to be very careful and to really record everything that happens on site that is eligible for EOT, can be approved for EOT claim, and also um, to really plan your work to avoid more EOT. Like example, in this one, you have a second EOT that changed the completion date to here, and then the third EOT it changed completion date to here. This is second one. And the third one, and the fourth, fifth, and sixth. So this the projection, but this is based on the uh, based on the physical, um, not on financial curve. But let's analyze this data at this S curve. As you can see here is up to this month, the first the master plan. So if you divide this into 3, so rule of thumb, quite satisfied lah, quite satisfied up to 50%. So the mid one third, mid the first third, two third, and the third one third. So you need to have this 50% here. So basically, this is satisfactory. How they plan the S curve is satisfactory. 50% is up to here, so it won't affect your cash flow too much. By right, it can be completed. It is viable for contractor to finish. But things happen at site. Especially this is housing project, government housing project. So housing project may involve a lot of changes in design, also in land acquisition, maybe that part of things. But uh, as I said in class before, you need to, aim of the project team is to deliver the project on schedule, not to expect extension of time. Project curve or S curve can be expressed as physical cumulative or financial cumulative, as I said earlier. So physical cumulative is based on planned schedule. Cumulative percentage of physical progress is plotted against time scale, usually months, and percentage is based on duration of each activity, while progress percentage is based on a grid joint measurement report. So um, first you plot your S curve. Previously in the lab session, we plot the S curve based on financial. So we can also plot based on the duration, as said here, based on the cumulative, based on the duration, percentage of duration of each activity. So you can plot, say you plot your S curve of physical, as physical. Say this is physical S curve. So what happened in the third statement is that I want to highlight that progress percentage. You want to plot your progress percentage. This is your guidance, your S curve guidance based on the plan program. So what you want to plot every month cumulatively is the agreed joint measurement. Let's say you have completed the pile cap. So let's say your contractor, you call for joint measurement, and then a representative for client came to the site and do joint measurement for you. So and then they highlight, then you agreed on certain measurement. So you measure, for example, you measure kilometers of road that have been completed by you up to crush run and then up to um, pavement. So you agreed based on the joint measurement percentage of the completion. So you can plot the percentage. Let's say you plot under the graph up to here. Let's say this is your April percentage, or joint measurement percentage. So April is here, but the plan is here, so you're gonna have your delay here. Let's say, and then in the coming months you expedite the work, so your progress joint measurement becomes here. So this is your ahead, percentage of ahead. So you can report your ahead. Very poor handwriting. So this is ahead. So this is ahead of schedule, so we can catch up. Then you meet on the progress up to the last percentage 100%. There is no EOT. So that's how you track. That's how you track. But if it is financial curve, right? Financial, say this your financial S curve. So this what we plotted in the lab session before. So what you want to track is your percentage of claim. How much you've been claimed. Let's say you have claimed 50% on August. On April you have claimed 50% here. So on financial curve there will be ahead, but based on the financial, but based on the physical, it won't be the case. It depends. Sometimes the task is very costly. Like example installation of M&E items, like air condition unit, chiller unit. So it costs like the material being one side also be can also you can also claim when the aircon is being has been delivered to the site, so you can claim. But the aircon has not been installed yet, so on financial curve it will be large because the amount is large. But on physical curve that might not be the case because the duration is small. So there's a bit difference, so you need to see both physical. Usually they are more concerned about financial curve. Some of the project, like I've shown this view, is more on physical curve. They want to see the physical S curve. So this is example on the physical S curve. If you want to do it yourself, or for example, if you are um, working later on in future, so you want to produce your own S curve. It is a bit easier using Excel. What you want to do is put your task here, and then the duration based on your, maybe you did your program on Microsoft project, so you input your duration here. So at the bottom row, so you total up all the duration here. You total up, so the total days for each task will be 1043 days. So these are days, the total days for each, combining all tasks. Why you want to do this? Because you want to know the percentage of each task contributing towards the total percentage here. So these are 100%. So this is your 100%. This is your 100%. So what you want to do is you want to calculate days, or for each end of month. So this end of May, end of June, end of July, up to here, end of March of 2025. So for example, in this prelim, so from the start date, from the start date, April 1st up to 31st of May. So there will be 60 days spent on prelim item and 53 days spent on mobilization. So this 60 and 50 contributes, if you divide it to 1043 days, so it becomes 5%, and this one also 5%, about 5%. So total up, at end of May, um, based on your plan, your program, you need to complete 10% of the work, 10%. Then cumulatively, this cumulatively 90 become 90 days, become 60 days. As you can see, for example, prelim, uh, prelim up to the end of March will be 100%, supposed to be 365 here, 365 days. So it will be 100% of prelim, but prelim only contribute about 35% to the whole project, because the 365 out of 14,300 is about 35%. So based on this cumulative, you can add up until the end of project. So this basically the value for your S curve. So you can plot your S curve here, so up until this day. So that is your S curve. So it'll be, in Microsoft Project, there's also um, tools for tracking, so similar to this. And the you need to track the project, but you cannot produce the SQ physical. You cannot produce the SQ physical. You can produce a progress, physical progress of the project, but and you can plot it, because Microsoft Project can help you plot based on this, based on your plan days, and then you can help you plot on each month. On each month, let's say this is your program, and then this is your progress. It easier to, but this method is for, um you want to do astrophysical manually using Excel, but on Microsoft Project, uh, Microsoft Project also have that kind of monitoring, where first one you need to go to your project, then you set your status date. Example, let's see, at end of 2024, which is on December, on the 31st December, set your, um, you set your project date, and then you set your, and then update your project. So here you can see your progress for each project. So what you want to do, if you want to plot your S curve using Microsoft Project, you need to set till the end of date on 1st October, and then you update your project. So everything will be completed, and then so what we will do is same as before. You can pick any uh, visual reports, but once the report has been produced, for example here, so you can pick your, under values here, you can pick your cumulative work, and then put your monthly calendar on axis category, and then on this assignment you expand the percentage here, and there you have it, your S curve here. So we will talk about this more on your lab session. So this is basically your work, but we'll talk about more on in our lab session. So I hope you gain benefit from this video and see you in the next video.